For centuries, the dream of discovering life beyond Earth has fascinated humanity. Thanks to the James Webb Space Telescope, that dream might soon become a reality. The telescope has revealed a fascinating secret in Proxima Centauri, the closest star system to us. Amidst its planets, Proxima b stands out with strange artificial lights, leaving the scientific community baffled and intrigued. Could this be the long-awaited evidence of intelligent life beyond our solar system? How do scientists determine whether these lights suggest the presence of intelligent life on Proxima b? Join us as we delve into how the James Webb Telescope just detected city lights 7 trillion miles from Earth. Humans have always been intensely curious about the secrets of the universe. Through technological innovations, our innate drive to explore the Earth and sky continues to push us. After thousands of years of civilization, Earth remains the only planet that we know to host life. As such, the age-old question persists. Are we the only inhabitants of the universe, or are there civilizations hidden among the stars, just waiting for us to find them? To find the answer to this difficult question, two American astronomers, Jill Tarter and Thomas Pearson, kicked off a project called the Search for Extraterrestrial Intelligence, SETI, in 1984. This nonprofit endeavor aims to sift through cosmic space, focusing on space-borne radio signals. These radio waves are capable of traveling immense distances and are the primary means for potential extraterrestrial communication. The successful launch of the James Webb Space Telescope is humanity's giant step forward in understanding the universe. The James Webb Space Telescope, JWST, is the most advanced instrument in the history of mankind to understand what the universe holds. Located about 1 million miles away from Earth, this giant telescope is our window to the earliest eras of the universe. It brings the previously elusive observation points closer, shedding light on the formation of galaxies, stars, and planets. Astronomers harness the JWST's capabilities, cutting-edge cameras, and filters to capture and analyze the intricate colors surrounding celestial objects. Through JWST, researchers are able to isolate and collect valuable information about the chemical compositions and physical properties of celestial bodies in the far reaches of the universe. They achieve this feat by isolating specific wavelengths of light. Beyond mere observation, JWST explores and investigates the atmospheres of exoplanets for traces of life. Its unequaled power to observe beyond the limits of time and space has led to some of the most remarkable findings. Proxima Centauri emerges as a beacon of potential at a distance of just 425 light-years from the Sun, making it the closest star to ours. This star can be observed in its faint glow, barely noticeable amid the darkness of the night sky. In a captivating revelation on August 24, 2016, astronomers discovered a planet with 1.3 times the mass of Earth, located within Proxima Centauri's habitable zone. This Goldilocks-like region offers a delicate balance of light intensity, as it is perfectly balanced to melt ice for water and potentially nurture the seeds of life. Proxima b is an astronomical paradox orbiting around Proxima Centauri, its host star. This planet, which is surprisingly only 4.6 million miles away from its small red star, has many situations threatening its ability to sustain life. Proxima b is very close to its host star, exposing it to powerful solar winds that can strip away its atmosphere and make it lifeless. But despite all these tough circumstances, Proxima b basks in the light of its tiny star, receiving enough sunlight to maintain Earth-like temperatures where the water is in the liquid form. The James Webb Space Telescope's state-of-the-art infrared imaging capabilities are well prepared to reveal the mystery of Proxima b's atmospheric components and give unique insights into the possibilities of living on it. Despite the daunting challenge of detecting faint artificial illumination against cosmic darkness, the JWST's advanced technology enables it to discern even the faintest glimmers of light. The telescope can sense artificial illumination, provided it falls within a frequency band 1,000 times narrower than the starlight. The presence of an atmosphere on Proxima b would suggest the existence of seas and raise the prospect of life. The quest to uncover signs of worldly civilizations on Proxima b has intensified, driven by the hypothesis that such beings may have devised ingenious solutions to overcome the planet's inhospitable conditions. The search for extraterrestrial life continues to push the boundaries of human knowledge and technological innovation, offering the tantalizing possibility that we are not alone in the universe.